Hey there, so just explaining task 5.2. I've built this graphical user interface that runs on the Raspberry Pi. Pretty much as the task explains, there's three buttons. They can be switched on and off. I didn't make it such that one button stops the other button switching. My circuit board doesn't really make sense for that. There's three independent lights. They switch independently. They give feedback independently. They aren't really linked together. So it's pretty straightforward to introduce logic that does that, but I haven't done that. Didn't think it really made sense. Anyway, so here's the GUI. So basically there's one page, power page, you've got three buttons. They switch independently. You can see this bottom part was just for feedback. The feedback also comes through on the button color, but I just wanted to have this down here so I could read off the states, make sure that the color was the color disappearing, mapped to false, the color appearing, mapped to true. There's three different color buttons. You'll see in the demo, the video demo, that there are three different colored lights. These are mapping, the top button is the green button and it also maps to the green light. Yeah, that's pretty much it. Some cool stuff. This thing goes open and close. This is a browser-based application, so it runs in the browser. Doesn't run the way like Qt would run, like as an executable. So it runs in the browser, which is cool for like modern day web applications. They run this same framework. Framework I used was Dash by Plotly. So it's like a Python wrapper on top of React components. So pretty flexible, does stuff. You can do lots of pages, do all the sort of similar stuff as React does. Doesn't have as diverse a widget like portfolio as React, but anyway, it's pretty good. It's also Python, so all the normal Python stuff works here, which was really handy in the case. I'll just swap over to the code and show you the integration with the actual like logic that drives the LEDs. So this is the code that drives the LEDs. So I've got a pretty large folder structure here. Basically played around with like Docker, deploying it on top of a web server, which is this Procfile stuff. But yeah, Dash gives you like the base application thing, which is pretty much this stuff in here. So you're running, you build this application thing up, you render the like home page, and you can run this application with like application.run. It runs on like 8080, port 8080. I'm running in debug mode right now. Yep. The Docker file isn't being used on Raspberry Pi, but it would be cool to do that, but I haven't. What else? All this stuff's pretty boilerplate stuff. So this stuff's all like the sidebar stuff, but the page that actually shows the buttons is this one here, and pretty straightforward. There's a library that uses DashDAC, is basically like a bunch of like industrial type stuff, and power buttons are considered like industrial type stuff. Pretty straightforward. These three power buttons are the three power buttons you saw on the screen. Their IDs, which is how they are referenced in the logic, are red, amber, green, amber, red, and by default they're off. This thing here is giving me a div into which I can put that result. The thing that red, the green button is false, the amber button is false, etc., etc. That result that's being passed back from the logic function is being put into this HTML div. The callback, so this is a page. This basically is like static content. It is only rendered, or the render only changes through these callbacks. So this callback here is an app.callback. It's taking in the state of these three buttons that I just showed you on the other page, and it's putting the result of this logic down here in that div that I just explained. So the actual LEDs is being switched here. So you can see, I've hard coded these like pins. Not great. This really should be done through config or something, so that a person can come along and change the red pin. Let's say pin 2 stops working. They can just change the config to pin 5, move the wire to pin 5, and the application keeps working without having to like recompile, rebuild the whole application. So that's that would be one improvement to this. I didn't do that, I hard coded. Yep, so anyway, these 3 buttons come in on inputs. The state gets read into these variables. I pass those variables, I pass the pin numbers and the state of the power button into this function that just does the switch LED logic. So this is basically that. Just sets the mode of the BC to the BCM type, sets them to output types, and if the state is high, so this is a state's a boolean. If the state's high, then it does this like custom GPIO.high, which I'm pretty sure is just a boolean under the hood, but I didn't look. So just use the library recommendation to switch these things. If it's not true, it's false, hopefully, unless there's some weird state that I don't know about. Then yeah, so in that case it switches it low, and then it just returns the state so I can get feedback on the thing. That's pretty much the whole thing. Yeah, so that's pretty much the whole like application explained. I've put the demo as well as the explanation in 2 separate videos just because I have trouble filming my screen and filming physical objects at the same time, because I've got to, screen filming happens through a different mechanism than physical world capture. So yeah, that's pretty much the whole thing. I guess you can see this is running on my Raspberry Pi. I'm SSH'd into it in Visual Studio Code, which is like really handy because you've got all the tools of Visual Studio Code, but you're on a Raspberry Pi, which, sometimes editing in Vim and like with Nano can get quite tedious, and this is much nicer than that. So yep, that's pretty much the whole thing. This is all committed up in the repository, the link's in the thing. That's pretty much the explanation I've got. Thanks.